Thank you guys for coming back to this tutorial, and we are looking for the domains and the range for the given function, for the following function. We have 5 examples, and the last time we did 3 of them. We did the square root, we did the fraction, and we did the absolute value. Okay, now we learned each of them has different restrictions, and that's why we got different answers for each domain set and the range. Okay, now we're gonna continue doing that. So number 4 is the p of x log. It's a log function. Okay, so we have a log function right here. So this log function, I typically like to show it in the exponential form. Right, I typically like to show in the exponential form. Assuming I'm not using p of x, I'm assuming a y. If I assuming this is just easier for me to teach and understand. When you see a log, that is called the common log. Okay, it's a common log that with a base of 10. You guys see that, right? It's a base log. And there's a transformation of the logarithmic form that allows you to do this. So this equation you can write as another equation. Ten to the y power equals to x minus 2. Right? The way he's writing that is wondering, oh, 10 to the how much power gave ye x minus 2? So he put the log. So this the purpose of logarithmic function, right? You want to know the power of the 10. Okay, this way is easier to look at it because I know the power base is a 10. Okay, it's a positive 10. Okay, if I have positive 10, positive to a positive power is always positive. 10 to the 10 power, that's how many, I don't know. But 10 to the 1 power I know is 1, is 10, right? But 10 to the 1, 10 to the decimal, it becomes some decimal left, right? But y can be negative, but negative only put 10 to the denominator. Like say y is negative 1, that means 10 to the negative 1 becomes 1 over 10. But 1 over 10 is still positive, right? So out of this case, the s equals to 2 always equals to a positive number. Do you see that? Do you see that? It's always equals to a positive number, and it always equals to positive, and it never equals to 0. This part never equals to 0 because as y goes to like negative infinity, like a negative, this becomes like 0.000001, but it's never equal to 0. It's really small, but it's not equal to 0. That means x minus 2 is always greater to 0. It's never equal to 0. Okay? If I put this way, x is greater than 2, I put the 2 over. Okay? And if you look at stats, it's from 2 to positive infinity. You guys understand this? You can understand this. Hope you understand this. Now let's talk about range. Range, we're looking for p of x. Okay, so p of x, where's the p of x at? I put that as y. It's right here. And as I mentioned, the p of x is power over 10. It can be positive, it can be negative, it can be decimal, it can be a whole number. This part has no restriction. It is whole number, all real number. That means I got those sets. from negative infinity to positive infinity. The trick about logarithmic function is this part. Inside of the logarithm, you can memorize this. You just memorize. Or if you don't memorize, you write it like this. You write it as an exponential form where you explain yourself better. Inside of the log, this is called argument, right? It's called argument. Argument is always greater or equal to 0. No, it's always greater than 0. It never equals. Always greater than 0. Okay. So that's been taken care of. Let's do E. E, let me cut it down. It's a Q of x equal to e to the 2x. Okay. This is this right here. The only thing that's different is those things reversed. The function comes here, and you kind of think, oh, domain range may reverse. Okay. Because 2x is on the power right now, and as I mentioned to this one, the power of the 10 has no restriction. That means 2x is being bounded by this. If you divide both sides by 2, it gives you this. Still infinity. Divided by 2, still infinity. That means I come negative infinity to positive infinity. Oh, another way of writing it. Or a number. Okay. Now, the g of x is a result of the exponential form here. And I didn't mention. How much is E? E is approximately equals to 2.71a and so on. 2a. This is you can consider approximately equals to 2.71a to some power, right? But for this case, it's the real number, positive number to some power, because this is not 0. That means this is not equal to 0, because this has some power to it, and no matter how small it is, like the one showed last time here, negative 10,000, negative 200,000, doesn't matter. This is gonna still be the same, still be the positive number. So this is all greater 0. This only case it becomes 0 is the base is 0. 0 to 1 power, 0 to 0 power doesn't really make sense. But 0 to 1 power, 0 to 2 power, 0 to negative 1 power, like that. Okay. So this is all positive from 0 to infinity. Okay, hope you guys enjoyed it. We talk about 5 different types of function: square root, fraction, absolute water sign, logarithmic, and exponential. Hope you enjoy it, and make sure you know the different types of function, and you know their restriction on their range, on their domain. Thank you for being here. Hope that clear about these exercises. Thank you.